Okay, so now I have to tell you the relationship between potential energy and potential. So remember, these two boxes still need to be filled. So I'm going to fill those two boxes yet. So let me define what potential energy is. The units that we used in Newtonian for potential energy was U. Do you remember that? And we put a subscript G on it, and it was mgh. So now this has to be a new formula, right? Because remember, U was, when we were talking about Newtonian, U mgh means what kind of a field was that in? Gravitational field. So now this is going to be a different U because it's now going to be in electric field. So the formula will change. Technically, the rest of the stuff will remain exactly the same. Okay, so how do I do this? I can start with my formula for work. Can I start with my formula for work? What was work? Force times displacement. In Newtonian, we wrote it as F dot dl. May I rewrite this? And so this is now going to be, instead of the regular force, is it going to be Fe? How did I define Fe in my box? Like that? I should put this in a box. Like this? May I replace that in here? Oh, and dot stays there, right? E dot here. Is Q a constant? May I take it out of the integration? Yeah. May I write this as W over Q? Look at equation number A. Or in fact, equation number B. Do you see similarities between the equation C and the A and the B? What's the similarity? E dot dl is exactly the same. So then may I replace this side by, this side by minus VB minus VA? So this also, we know, work from what we put in the box, work kinetic energy theorem or minus potential energy. Do you remember that? The first part is the work kinetic energy theorem. The second part is the conservation of energy. So may I replace my W with my U? And this with delta V from here, right? This is delta V. Agreed? So the relationship between U and V, drum roll, is given as that. And in textbooks, this is generally, you will find this as written as delta U equal Q delta V. You'll see this written as that. Or even simply U equals QV. So in words, potential energy per unit charge is equal to potential in electrostatics. Now I'm going to start filling that box up. Can I start filling boxes up there? Okay, so going back to my box, what should I put here in my first box? What's the symbol? V. What's the symbol here? W or U? Potential. Fancy equation is equation number B. But you know how I remember it? I call it the ED equation. So I usually remember, I don't remember where I read that, but I think in one of the textbooks, they used to call it the ED equation. How is it the ED equation? V equals ED. That simplifies to this. Okay, so this is what I want you to put here. Potential is what gets developed when you move a charge in the field by the distance d. Do you see how the E field is the important factor in all of this? E field is what we should start with. E field determines the force that a charge experiences and also how much potential it will develop when it moves through it. And then how do we define work or potential energy? So work can be defined as Q delta V. That's how most textbooks define it as. And U, which is the potential energy, is defined as QED. Do you see the relationship developing between this and this? And in integral form, I want you to write also here, V equals minus E dot dl, or E equals partial V over partial X with a minus sign. Do you guys see all this, that I'm just moving things around and these are not new formulas? Do you guys see that? Is that obvious? So between the pink, the red, and the blue in this box right here, do you see that these are not really new formulas? I'm just moving things around depending on what I need. So now how do these formulas vary if I have charges Q1 and Q2? And this is what you're going to find in textbooks. If you have charges Q1 and Q2, I'm going to keep this hierarchy of this picture. I'm going to redraw it here. So I'm going to draw my circle here. I'm going to move it over, and like this. So for two charges, Q1 and Q2, how do these formulas change? What will be E? What will be the force? What will be the potential? And what will be the potential energy? Another thing I want you to know, this is a scalar.
For that one right there, is that KQ over R?
Which one?
The V equals.
Yeah, that is KQ over R, 1Q.
Okay.
Potential has 1Q. right? Potential is just taking your charge and moving it in the need field. So if you were to take E and do a E dot dl over it, it will get you from here to here. Whereas these both are vectors. Or even if you were thinking about this, this is just, how do you get from here to here? It's E dot D, right? It's the ed equation that brings you here. So just one of the R's goes away. And how do you get from the E to the F? F is just equal QE. And also another thing that you should write on this is their units. So the units for force are newtons. The units for E field are newtons per coulomb. The units for potential are joules. Potential energy is joules. The units for V are joules per coulomb. So how do you go from here to here? You have to do U over Q gives you V.